The topic of this video is simplifying radicals. To simplify a radical, first, verify there is no addition or subtraction under the radical. If there is, the method I'm about to teach you will not work. Then write the prime factorization of the radicand, which is the expression under the radical, and create groups of matching factors. Each group must have a number of matching factors equal to the index of the radical. For example, a square root requires groups of 2, a cube root requires groups of 3, a fourth root requires groups of 4, and so on. Each complete group's matching factor leaves the radical to become a single multiplying factor outside. Any unmatched factors remain inside the radical. If all factors leave a radical, then the radical symbol is removed. For example, the square root of the sum x squared plus y to the sixth cannot be simplified because of the plus sign. But the square root of x squared times y to the sixth can. First, write the prime factorization of the radicand. X squared is written as x times x, and y to the sixth is written as y times y times y times y times y times y. Because this is a square root, the index, which is the hidden number 2, normally shown right here where my cursor is wobbling back and forth. Because the index is 2, we need groups of 2 matching factors. So the x and the x form a group of 2, y and y form a group of 2, the second y and y form a group of 2, and the third y and y form a group of 2. Each complete group's matching factor leaves the radical. So one x comes out, one y comes out, a second y comes out, a third y comes out, and because all factors left the radical symbol is removed. Now combine everything together. X times y times y times y gives you xy cubed. Let's do another one. Cube root of negative 8a to the sixth c cubed. First, write the prime factorization of the radicand. Negative 8 is the same thing as negative 2 times negative 2 times negative 2. A to the sixth would be written as a times a times a times a times a times a. C cubed would be written as c times c times c. Now that the index is 3, we want to make groups of 3. So, there's a group of 3, there's a group of 3, there's a group of 3, there's a group of 3. Each group sends one representative outside of the radical. So outside we get a negative 2, an a second a c, and combining these gives us our simplified result, negative 2a squared c. Next one, fifth root of 32b to the 10th. Well, 32 is 2 times 2 times 2 times 2 times 2. b to the 10th is just 10 b's being multiplied. This time we form groups of 5. Well, there are 5 2's and there are 10 b's, but we can break the b's into 2 groups where each group has 5 b's in it. This is kind of like dividing. 10 divided by 5 gives you 2. This inspires a shortcut that you'll probably learn to use when simplifying radicals. But let's continue. Each group sends one factor out, so we get a 2, a b, and a second b. Putting these all together, we get the simplified result, 2b squared. Now, in all of the examples we've talked about so far, we had perfect groups. But what if that's not the case? What happens then? Well, let's look at this cube root. The cube root of 16z to the fifth. 16 is 2 times 2 times 2 times 2. Z to the fifth is z times z times z times z times z. And because this is a cube root, we need groups of 3. Well, we have 3 2's with 1 left over, and we have 3 z's with 2 left over. Each group sends one factor out, so we have a 2 and a z outside, but the 2z unpaired underneath stay underneath. So that 2 times z is multiplied by the cube root of 2 times z times z. Simplifying the outside and the inside gives the final result, 2z times the cube root of 2z squared.